Good morning. I just want to share with you about what is on eCampus. Okay, I posted, let's see, let's go to the eCampus right now. Okay, so I posted the TI-84 in here. Okay, so if you go to eCampus, you can see I did post the TI-84 emulator, which you can download. You can go to the education.ti.com and then go to download the tape and choose the TI-84. You can download this one, and this looks like the one I have in here. Okay, so I show you the calculator I have. There's another one is a little bit easier, a little bit simple. It's a TI-83. This one, the TI-84 from the TI company, this one has a 6 months subscription. Okay, so you can, this is the one I'm using right now. But I also posted another TI-83 Plus. You can download this one and unzip it, and then click the .exe version. So this is the one looks like this. All right, so that is the TI-83, 84. That is this one, the zip file. It will look similar like this. Okay, the subscription from the TI company, this is the newest version, and it will look something like that. Okay, so this is the TI. It will telling you, you can have a continue with the trial version. So, but for this one, after you download it, you will have to reboot the computer in order to make it work. Okay. So after you download, and then you will make a after you download, you have to restart the computer, so it will work. So this is the trial version. You can have a 6 month, which is plenty for the course anyhow. But if you're using the zip file, I upload on eCampus, and this one doesn't have an expiration date, so you can use as long as you need. Okay, but this one, a little bit simple. This one is a little bit newer version, so it got more features in here. Okay, so that's the calculator. Some people were asking last time I did post it on the eCampus in here. All right, so just go to the eCampus and look at the formula TI-80 TI calculator in here. Okay, so that way you will be able to make the download from here. Okay, that is in here. Another one is the test review. Okay, so that's the one like you have a test 1, test 2 review. So this is giving you a little bit additional review from the chapter. Okay, but this doesn't substitute. You still have to do the mastery test, which is the one on my Net Plus. Okay. All right, so I have a couple of people ask the question earlier. So I'm going to go ahead and answer those 2 questions first in here. Okay, so let's start sharing this one, and then I'm going to upload a file in here. Okay, so let me go ahead and add this one. Some people will ask last time, so I put it in here. I download it. Frequently asked question. Okay, so those are the 2 questions I received from the email about the homework. Okay, so let's look at the first one right here. Okay, so the first question, it was from the 1.1, section 1.1. You want to find the distance between the points, giving and you have to give the exact answer. Okay, so I want to explain what does the exact answer mean. the exact answer, that means you will have to keep the fraction like 1/3 is the exact answer, okay? If you, and then you run to 3 decimal places. And then if I run, this will keep repeating on 3, right? So this will be 3.33333, keep going on 3. So I will have to just need to keep 3 decimal point. So I'm gonna have to run to 3 decimal, so 1, 2, 3. So I run to 3 decimal point. And this is regular rounding. You will need to look at the next digit in here. If I say I want to keep 3, I have to have this 3, right? And the next digit in here, the fourth digit, if 4 below, we round down. 5 above, we round up. So this one is 3, so you round down. So that will be the final answer. Okay. All right. So that's how you keep this is called the exact answer in here. All right. So let's go ahead and do this one right here. How do you find the distance? How do you find the distance in here? Well, if you want to find the distance, you have to use the distance formula, right? So this is a distance formula in here. I usually like to suggest to mark this one, like this one is x1, and then this one is y1, right? The first point. And then the second point, I like to mark this one is x2, and then this one will be y2. Okay, so if you mark this one on your own, it will be easier to plug it into the formula. Okay, so when we plug it into the formula, it will be much easier. Look at it. So my x2 will be 1 in here, right? This is my x2. So my x2 here is 1 minus x1. Well, my x1 is -7, so I have to have a small parenthesis here for my x1 in here, okay? And then we square them, and then we plus the y2, which is, look at that, my y2 here is -17, right? Minus y1, okay, minus y1, which is -9, okay? And then we have to have a square right here. So that is how we plug it into the formula, okay? Go ahead, give it a little bit mark in here. So x1, y1, x2, y2. And then when you plug it in, it will be a little bit easier. So you don't make a mistake that way in here, all right? So we're gonna go ahead and do a little bit calculation. Minus a negative is plus. So we have a 1 plus 7, right? Negative become positive. 1 plus 7 squared. Okay, and then we have a -7, -17, -17. Negative, get rid of inside this first, right? Negative become positive. So I have a +9 squared. Okay, all right. And then we're gonna go ahead and calculate this one right here. So this 1 plus 7 will be 8. So I have an 8 squared, right? And then -17 plus 9, this will be negative what? -8 squared. Okay, and the positive square is positive, so that's 64 plus negative square is also positive, right? This is kind of -8 times -8, so it's also 64. Okay, so what do I get in here? I will get 128. Okay, so 128 in here, but this one is the final answer, but we have to simplify this one. Okay, even we want to write the exact answer, but you have to simplify. Okay, so if you can take out anything, just like if you have a final answer as a square root of 4, right? You have to simplify. Square root of 4 will be 2. So this will be the final answer in here. Same thing, 128, I have to simplify. So how do I simplify this one right here? Well, first, 128 is an even number. So all the even number can be divided by 2. Look at it. I'm going to break down this one in here. Okay. So when I divide it by 2, what do I get? I got 64, right? And you can see this one will be 2 times 64, and 64 is 8. Or if you don't know, you can keep divided by 2. This is kind of like a tree, right? 64 divided by 2, you got 32 in here. And then 32, you divide by 2, you got 2 and 16 in here. Look at that. And then 16, you can divide by 2 again, and this will be 8, right? And then A, you can divide it by 2 again. This will be 2 and 4. And then 4, you can divide it by 2. You can 2 and 2 in here. All right, so that's a lot of 2 in here. So we can see this 1, 2, 3, 4, 5, 6, 7. So I can write down this one as 2 to the 7 power. Look at it, 128. I can write down as 2 to the 7 power, right? But if you know this one, 2 to the 7 power, of course, this is square root. Square root is root 2, right? So 7 have to divide it by 2. But cannot be divided by 2, so I'm going to have to break down 2 times 2 to the 6 power. Okay, 2 to the 7 power, I can write down 2 to the 1 power and times 2 to the 6 power in here. And 2 to the 6 power, I can divide it by 2, take the square root out, right? So this will be 2 cubed, which is 8. All right, and then 2, I cannot take the root out, so I have to keep it inside. So 2 cubed is 8, so this is 8 square root of 2. So this is called the exact answer. So that is the one you're going to have to type it into the calculator. Do not type a square root of 128 because you didn't simplify. You always have to simplify in here. So, or if you kind of familiar with this one right here, you can write down as square root of 2 times 64, right? And you know 64 square root is 8. So you can have an 8 square root of 2 if you kind of familiar with the square root. So square root of 64 will be 8, and that will be right here. You know, you get this one right away. But if you do not know, you can always break down by 2 when it's an even number, right? You can break down by 2 in here, and then count how many 2 in here. In this case, is 2 to the 7 power. So you have a square root of 128 is equal to 8, 2 square root of 2. So that is the exact answer you need to type into the find the exact. So the exact answer here is 8 square root of 2. Do not type a 120. Do not type a square root of 128. This is unsimplified. Just like if you have a final answer as 2 over 4, right? If you have a final answer as 2 over 4, if you type it into calculator, if you type it into the homework minus plus, it will counter you wrong. You have to simplify into 1 over 2. Okay, you always have to simplify. Same thing as the square root. Square root, you have to simplify. Whatever you can take it out, you have to take it out. So your final answer should be this one right here, should be 8 square root of 2. Okay, and then we're going to run to 3 decimal points. So there's another answer here. So how do you run to 3 decimal point? Well, if I want to run to 3 decimal point, I can either using this one or this one type, run to the square root of decimal point. So I'm going to switch to calculator. Okay. All right. So let's switch to calculator. Stop selling this one, and I'm going to switch to the calculator. Let's see. Okay, calculator. Oh, hold on. Right here, cell application screen calculator. Okay, so I'm going to do the calculator here. So how do you type the square root? Well, when you have this second, you have a blue color. Square root is in the blue color here. So you have to have a second x squared. That's a square root, right? So you type this one right here. So 128. Okay, and then you hit enter. All right. So if I want to run to 3 decimal point, look at that. I have 11.313, right? This is a 3 decimal point I have to keep. And then I have to look at the next digit. My next digit here is 7, which is 5 above. So I have to run up here. I have to run up. So my final answer should be 11.314. Okay. And if I use the simplifier 8 times the square root of 2, I should get the same answer in here. Okay, I should get the same answer. Look at it. These two, this you simplify this one, you got exactly the same answer. All right. And then if you run to 3 decimal point, so we have a 11.3137. We only need to care about the next digit here. So this will be 11.3114. Okay. All right. So let's go back here. All right, so our final answer here, our final answer, we plug it in, right? So this answer is 128 in here, and simplify is a square root of 2. So this is the exact answer you need to put. And then if you estimate into 3 decimal point, remember this is 11.3137, all right? And I only want to keep 3 decimal points. So this is a 3 I want to keep. But I have to look at the next digit. Next digit, if you 5 or above, you round up. Okay, 5 or above, you round up. If you 4 or below, you round down. You get rid of them. Okay, so when we round to this one right here, I will have to have 11.314. And that will be the answer in here. Okay, this will be the answer for round to 3 decimal point. This is called the exact answer in here. All right, so I want to give you another exact. How do you simplify? So for example, if I have a square root of 18, how do I simplify this one right here? Well, you can see square root of 18, this is 2 times 9, is that right? And 2 times 9, look at that, I can have a square root of 2 times the square root of 9, right? And then square root of 9 is 3, so this will be 3 square root of 2, and that's called the exact answer. So I cannot type a square root of 18 into the homework. I have to simplify. I will type a 3 square root of 2, called the exact answer, okay? That is very important. And then another one right here said, like if I have a 125, right? Square root of 125. And then if you can see anything end up with 0 or 5 can be divided by 5, right? So when I divide it by 5, this is 5 and 25. All right, if you divide it by this one. So, and then I can write down this is the square root of 5 times the square root of 25 right here, right? So how much is square root of 25? That's 5. So that's 5 for square root of 5. So this is my final answer, the exact answer. I cannot use the square root of 125 for the final answer, but I will have to type a 5 square root of 5. Okay, so that is giving you a little bit example on how to simplify the square root, and which is very important, right? Because even if the calculation everything right, but if you do not simplify the square root, or if you do not simplify the fraction, the homework will always counter you wrong. Okay, so you cannot leave the final answer as 3/6. You have to simplify. This is divided by 3, so that's 1/2. So you have to use the simplified one. Same thing as this one. If you have a square root of 125, you have to simplify. That's 5 squared. Okay. All right. Any question about this one? Any questions? That is some people ask in the homework. Okay. So it will be a little bit easier to answer this in a video than type this in a, in the checker. Okay, yeah, that's another question here is Abigail ask this one right here. Okay, I already put this question. Is this the question you were asking earlier? Is that right? Yeah, okay, so yeah, this is the one I asked her in here. So I already put it in here. So I copy this one down. So let's talk about this one right here. Okay, this is the one Abigail was asking in here. A daycare center has 24 feet of the dividers, which to enclose a rectangular play space in a corner of a large room. Okay, in the corner. So what does the corner mean? Well, this is kind of like the corner. Okay, this is the corner. All right, so this is the room, right? So this is the corner in here. Okay, the size against the wall require no partition. Suppose the play space is x feet long. Answer this question. You have 3 questions here to answer. Okay, so I'm giving you a total length here. The total length here, this is 24 feet. Okay, 24 feet dividers. So I want to I want to enclose in a rectangular play space. So that means we're gonna just need to a rectangular. So what does rectangular mean? Rectangular is something like that, right? This is a rectangular. space in here, right? So, but we already have a corner here. So that means we don't need to build these two sides. We only just need to build another two side in here, another two sides. So this is the one we need to build. Okay, we don't have to build the purple one. We only need to build the blue one in here, since I use the corner in here, right? Okay, suppose this space is s feet long. So if I have this one is x, and how much is this side here? Well, my total here is 24, right? This one plus this one is 24. So the other side must be 24 minus x. So this is the length and width. Okay, so if I let my length L equal to x, right? And my width here, this width here is 24 minus x. Okay, since it's rectangular, what does the rectangular mean? Rectangular, that means these are all perpendicular. These are all 90 degree. These are all 90 degree, right? These every corner are 90 degrees. That's the rectangular in here, and also the opposite side equal. Okay, so this side we are equal to this side, and then this side we are equal to the next side. All right, so that is the rectangular in here. All right, so what is the formula? What is the area for the rectangular? What is the area for the rectangular? We say the area for the rectangular is length times what? Width. We use this one very often, okay? And what is the perimeter? What is the P here? Well, perimeter is the sum of all the four sides, okay? So if I have this one is L, this one is W, right? So I will have L plus this is another L, this is another W. So perimeter is the sum of all the four sides. So I have L plus L and then W plus W. Okay, so my perimeter for the rectangle, we simplify, will be 2L plus 2W. Okay, all right, since this one, I don't have to build these two sides. I only need to build this side and this side. So that is, so actually in this particular equation, my P will be just L plus W in this particular equation here, because I don't have to build these two sides. So what does 24 feet mean in here? Well, 24, that means this whole thing is the perimeter in here. 24 feet is a perimeter, okay? But since I only need to build the two sides, so if this side is x, the other side will be 24 minus x, okay? And we're gonna plug this one in. So my L is x, right? And my W here is 24 minus x. Okay, and then we're gonna go ahead and simplify this one. So I multiply that in. So this will be 24x minus x squared, right? X times x will be x squared. So that is my my area in here. Okay, you will have this one right here. Or if you want to write down in a descending order, this will be negative x squared plus 24x, whatever you can. I think in the homework, if you write this one or write this one, should be all correct in here. Okay, and another one is you want to find the maximum value for the x, trying to see how do you, so giving you this 24 feet of this material, right? How can you build the maximum area? We want to this area the max. So after we learn the chapter 3, we're gonna come back to redo this one again. We're gonna have a formula. After we learn the quadratic equation, find a vertex, we're gonna have a formula to find the maximum area. But for this case, right now, we don't have a formula. So we're gonna just using the graphing method, okay? So that's why you need a TI-84, which I just posted on eCampus. So you're gonna either graph this one or graph this one. These two are the same, right? And then what is the A? A here is the Y. A here is the Y here, okay? So if I graph this one, 24x minus x squared. If I graph this one right here, I will go to the graph and look at the y maximum, right? So let's go ahead and graph this one in here. Okay, so I'm gonna switch to the calculator, graph this one. Okay, so let's switch to the calculator in here. All right, and we're gonna graph this one in the calculator. Okay, so let's see, go to y equal to, right? And I'm gonna clear everything in here. So I will have a 24x in here minus x squared. X, if you have a square, you can use this one directly, or you can use the power button, power of 2, that giving you the same. Okay, and we hit enter. So we're gonna go ahead and graph that. All right, when you graph that, you don't see the whole thing, right? As I told you earlier, go to Zoom and go to Zoom standard. You can use the Zoom standard, which is number 6. Oh, Zoom standard doesn't work very well, so I'm gonna using this one right here called Zoom Fit. Okay, Zoom Fit is a very good feature in here. All right, but if Zoom Fit looks like this is my highest one, so if I don't see this one right here, I can go ahead and manually adjust, because I want to see a little bit right hand side, right? So I go to Zoom Fit, and then you can put the window here a little bit. Go to the window in here. So I like to see a little bit. I don't need to have a y. I'm gonna have a y minimum as 0, right? And this is maximum 140. That's fun. But I want to have an x maximum here like a 20, because I want to see a little bit on the other side in here. Okay, so looks like this have a max in here. I still couldn't see the top one, so the top got truncated in here. So I'm gonna have to adjust my window a little bit. I can start with 0. I don't really need like a negative in here. And looks like this maximum is really big, so I'm gonna using 200 instead. Okay, using 200 in here. And delta x, I can give you as 1. Let's see what happened in here. Okay. All right. So let's, oh, now it's too small, right? So I'm going to leave those as default. Okay. Too small in here. Okay. So let's put a 0.1 in here. Oh. All right, so that look a little bit better in here. Now we can kind of read this one in here, right? So another thing is you will have to look at the x value, since the x represent the length. X represent the length for the application, so x cannot be negative, right? X is the length for the rectangle, so x must be between 0 and 24, because your total is only 24, so x must be between. So it looks like we have a peak right here. Whatever the peak is, we don't, if you have a clear calculator, you can read it, but we don't really have to read the maximum area. We just have to read when the x value where you have this is the maximum, right? So I'm gonna go ahead and using a little bit ruler in here. So looks like this is in the max in here, right? So how much is the x in here? This looks like x is in the middle. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So looks like when x is 12, this is to the maximum, okay? Because this is the max for the y. Okay, whatever the max is, this is the max from y. So I'm gonna look at this one right here, and then trace down in here. So we have this one in here. Okay, so that is the graphing in here. So we have an x. So now we can say when x is equal to 12. Okay, when x is equal to 12, this will be the max. Okay. So we have a answer here. Okay, a of x is equal to 24x minus x squared, which we already graph in here. Okay, graph in here. So in this case, x must be greater than 0. Okay, and less than 24. Why is that? Because my total length is only 24. So that and this I have to separate into two pieces, right? So and then we graph this one right here. So we have something like that, and then we can see this one. This is the x value, and then this is a y value in here. So that is x value. So this one, in this case, this is a maximum y. Okay, this is a maximum y in here, and then we write down this one right here. So this looks like a we have 24x. I'm sorry, there's x in here. Okay, so this when x equal to 12, this is a max. All right. Okay, so find it from the graph. Okay, so when x equal to 12 feet, this will be your y will be the max in here. All right. Did I answer your question, Abigail? Okay, John was asking where are the test links located and when are the due dates? Okay, so the test, John, test is on my lab plus. Okay, so it's inside of my lab plus in here. So I'm going to show you a little bit the test link in here. Okay, one thing is you don't have a test. Do not have test. Okay, do not have test until chapter 2. Okay, do not have a tears chapter 2 until you finish chapter 2. Okay, so chapter 1 is only 2 sections. We don't have a test. We might have a little bit quiz for the chapter 1, just probably 1 or 2 quiz. Okay, but yeah, it will be all on what? It will be all on my lab plus. Okay, everything the test, the quiz will be all on my lab plus. So you don't have a test until you finish chapter 2, which you need to finish this week for sure, because we only have 2 weeks. So we need to finish this week. Okay. All right. All right. Not a correct form. Then I put X. Let me say I got it wrong. Okay, make sure you have a number change. Okay, this one is 24, and you might change it into 28. Okay, so let's see if we just the format in here, we can you can say it said do not simplify. So I think the format, whatever format they want in here, we can look at the format later on. Okay. So I think the format it should be this one, or you can just try this one. Try the x squared, negative x squared plus 24x. This is in a descending order. Okay. Try this one to see what happened in here. All right. So that is the one I have, and I want to go ahead and give you a little bit review about the domain. Okay, that is another very important one here. Another important concept for the second question is the domain. Okay, I want to share you with the domain in here. Okay, that is not this one. Let's delete this one. Oh, hold on. Okay, another very quick and important concept here is called a domain. Okay, so how do you graph this kind of, where can you find a calculator on eConnect? No, you cannot find a calculator from eConnect. Everything about the course is on eCampus. Okay, I got a question here is saying, where can I find a calculator on eConnect? Don't go to eConnect. You have to go to eCampus. Okay, and if I come in earlier, or you can rewatch the video later on. In here, at the very beginning, I show everyone on where to find the calculator on eCampus, not eConnect. Okay, it's under the left-hand side. You have a formula and a calculator. Okay, if you don't know, you can watch this video earlier. We record this one, so you can find the calculator. So I giving you that calculator link so you don't have to buy one, all right? Because it costs probably $90 or $100 for a handset calculator. All right. Okay, so another one right here is I want to, this is the chapter 2, okay? Chapter 2 here, this one, another one is graphing the function, okay? Graph the function in here. All right. Graph the function here is, this is called piecewise, okay? So what is a piecewise in here? Piecewise, that means that is another important one in here, piecewise. So that means the pieces make up a one together, okay? So hold on, let me go ahead and erase, refresh this one because this just got highlighted in here. All right, so how do I graph this one right here? This graph, this one, if you put this one in a calculator, you graph everything, right? Graph x for the, from negative infinity to positive infinity. But this one, we want to graph just for x less than 1, you have this one. When x greater than or equal to 1, you have this one right here. So how do you make this kind of graph? Well, first, in order to graph the linear, you will have to have 2 points, right? So I'm going to have x and y. I set up the 2 points. So for this one, y is equal to 2x minus 3 when x is what? When x is less than 1. X is not include 1, right? So I will choose x equal to 0. Or I can choose x equal to -1 in here, right? So because 0 and -1, they are all less than 1. So how do I graph this one? So 2 times 0 minus 3, that's -3, right? And then this is -2, 2 times -2. So this will be 2 times -1. I'm sorry. And then minus 3, right? So when x equal to -1, so that's -2 minus 3, this will be -5. So I have a 2 point I can graph, okay? So I can graph in here, I can graph this one, okay? I have an x, y in here, okay? So I have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? And that's 1, 2, this is 1, 2, 3, 4, 5, 6. Okay. All right. And this one I have a -5. So I'm going to have to go down 1, 2, 3, 4, 5. So -5 right here. Okay. So when x equal to 0, this will be -3. So this is 1 point right here. 1 point right here. When x is equal to -1, this will be -5. So -1, this will be -5. So somewhere right here. Okay, so I'm gonna graph this one, and then which way to go? This one gonna that's -1, so I'm gonna have to connect these 2 points and extend this one for that. But I have to graph this one when x is equal to 1, right? So this one is a tricky point in here. I have to extend when x equal to 1. Let's calculate when x equal to 1. How much is this? When x equal to 1, this is 2 times 1 minus 3 is -1. But I don't have an equal sign, so I will have to exclude this point. Okay, so 1 and -1, 1 and -1, which is right here, 1 and -1 right here. Since this one don't have an equal sign, so I'm gonna have to using a circle in here. So I will have to extend this one to touch it when x equal to 1. But using the circle point. Don't use the solid point. Okay, when you're using a circle, that means touch the x equal to 1, touch this one, because I can have x equal to 0.9999, right? This one still less than 1 in here. So how do I graph this one that is close to 1? I will just graph this point and using the circle. Okay, so and I cannot go this way because I will have to have x have to be less than 1. So I cannot go the other way in here. All right, so similar, we're gonna graph y equal to x plus 1, and x is greater than or equal to 1 right here. So we're gonna do another one right here, another x and y, right? This time is y equal to x plus 1. This time x will be greater than or equal to 1. So this time I can have x equal to 1 right here, right? So when x equal to 1, y will be 2. but I cannot choose 0 because for this equation, because x has to be greater than or equal to 1. So when I have x equal to 2, this will be 3. So now I can graph this one right here. So I have a 1, this is 2. And this is 2 right here. This is 2 right here. And since I have an equal sign for this, so I will have a solid point. So this one will be a solid point right here, a solid point in here, right? When x is equal to 1, y is equal to 2. When x is equal to 2, this will be 3. This will be 3 in here. So this will be 3. So it's somewhere right here. All right. So and we're gonna just connect these 2 points and then extend it in here. So this one is for y equal to x plus 1, x is greater than or equal to 1. So now we have these two called a piecewise, okay? P-I-E-C-E. This is a piecewise function in here. So we have two pieces of the graph within the one x and y, one Cartesian system, one x and y coordinate system. We have two pieces in here. Okay, so that's how you graph this type of called a piecewise in here. Okay, any questions? You just have to be able to control the x and y in here. Okay, all right, this is probably the most challenging graph, right? Because you have to control the x value in here. You have to control the x value, okay? And then this one, x will be less than 1 in here. All right, any questions? Okay, so let's call graph the piecewise function. This is in chapter 2 already, okay? All right, let's go ahead and look at this is 2.2 in here, okay? So that is about the function calculation, and I want to talk the domain, okay? Domain is a very, very important concept in algebra. Pretty much every chapter in here, you're gonna have to consider as domain. But domain actually is not that difficult. Okay, you only need to meet 2 rules. Okay, I already listed in here. If there's an x in the denominator, okay, the rule here is the entire denominator cannot be 0. It's not. Sometimes people say, "Oh, x cannot be 0." This is not a exact. This is incomplete answer in here. How about if I have a So if I have a y, look at that. This is giving you an example in here. If I have a y equal to 1 over x minus 1, right? So what is my domain x in here? So look at that. If now I have x in the denominator, right? But the entire denominator cannot be 0. So my entire denominator is x minus 1. Cannot be 0. So we're going to solve this one right here. That means x cannot be equal to 1. So that is a domain in here, okay? And how do I write down this one in an interval notation, which is a lot of time in our homework, it asks you to write down an interval notation, okay? I posted a little bit interval review on the eCampus start here. All right, so how do I write down the interval notation? I have an entire x. So I have a 0, I have a 1 right here. X can be anything except 1. Okay, so that means I will have to circle this one out. So x can be anything to the left or anything to the right. Okay, so how do I write down this in an interval? Now I will have a negative infinity, common 1. Since I cannot have an equal to 1, so using the parenthesis, and then union from 1 to positive infinity. Infinity always using parentheses, okay? It doesn't matter positive or negative infinity. Infinity always uses parentheses. When you use the equal sign, okay, I'll give you a little bit interval in here. So this is between 1 and 7. All right, so if I have x greater than or equal to 1, less than or equal to 7, what does that mean? How do I write down? How do I use in the interval? Well, this interval, this side, I have included 1. So this 1 will be the solid point, right? And then this doesn't include a 7. So this 7 will be a circle point. So x can be anything in here. Anything in here. Okay? Sometimes another notation in this case is you can using the bracket or parenthesis. When you have an equal sign, you're using the bracket. Okay? Another, and then you don't have an equal sign, you're using the parenthesis. This will be similar like an interval. So my interval here will be from 1 to 7. Okay, 7 using the parenthesis because I don't have an equal sign. Think of this bar like an equal sign. When you equal sign, you're using this bracket. When you don't have an equal sign, you're using the parenthesis, right? So this looks like an equal sign right here. So since my x, I have an x greater than or equal to 7, so I will using the bracket for the 1, but using the parenthesis for 7. Okay, that is how you write down the interval notation. This is called the interval notation in here. All right. So since I have an x cannot be equal to 1, so 1 can be anything very, very close to 1 from the left, or anything very, very close to 1 right, but cannot be equal to 1. So that is the interval notation in here, from negative infinity to 1, and then unit 1 to infinity. Okay, so that is a domain for the first one right here. The second rule here is when you have an x under the square root, or any even root. So what is the even root? Like a root of 2, that's a square root, right? And then root of 4, that's even root. Okay, how about the cube root? Well, cube root is not an even root. So when you have a cube root of x, what happens with the x? X can be anything, can be any root, all real number. That's the cube root. So this rule here is only applied to the what? This rule here is only applied to the even root. Only apply to the even root. Square root is part of the even root. Okay, the radicand cannot be negative. What does this one mean in here? So if I have a x, I have a y equal to square root of x minus 1, right? Everything under the square root is called radicand. Okay, so what does that mean? That means since my square root is the even root, right? So this cannot be negative. What does cannot be negative mean? Must be greater than or equal to 0. That cannot be negative. It can be 0. So my domain here for this one will be x greater than or equal to 0. And then I solve for x, x will be greater than or equal to 1. Okay, so how do I write this interval in here? Well, my interval in here will be 1 to infinity, because I can equal to 1, right? So if I graph this one in here, this will be 1. And then 1 will be a solid point, and then 1 all the way to infinity. Or you can use the bracket here, okay? So this is the graph for the x, okay? And this will be the interval for the domain in here, okay? So that's called a domain. And actually, it's pretty easy. You only need to satisfy these two rules in here. Okay, when you have anything under the square root, everything, this one has to be greater than or equal to 0. How about some people say if I have a x is only square root, y is only square root of x. Well, if you only square root of x, now this radicand will be just x. X will be greater than or equal to 0. It'll be easy, right? So that will be the domain for this one. Okay, so domain actually is pretty straightforward in here. All right, some people say, how about if I put this square root we have earlier, put this square root in the denominator? Well, if I put this square root in the denominator, I have to satisfy both conditions, right? So first condition, denominator cannot be 0. So x minus 1 cannot be 0. That's condition number 1. And I also added the square root, so x minus 1 cannot be negative, right? So it can be greater than or equal to 0. So if you combine these two rules together, x minus 1 can only be greater than 0. Look at it. This cannot be 0 because it's inside the denominator. So when I solve this one, x will be greater than 1, right? So this will be just parenthesis 1 to infinity. That will be my domain for this one. So this will be the complicated one, not so complicated. This is the one you will have to meet the two rules in here. So meet the denominator, meet the square root in here. Okay. All right, any question about the domain? So you just need to remember these two rules. All right, okay, let's look at this one right here. So if I giving you this one right here, giving you f of the x and g of x, okay, f of x is x minus square root of, sorry, f of x is x minus 4, right? G of x is square root of x plus 5. Can we do this one right here? The answer is yes. This is 2.2, okay? When you have a f plus g of x, what does that equal to? Well, this is just equal to f of x plus g of x. Okay, so it's very easy in here. All right, so what's my f of x? My f of x is x minus 4, right? And then what's my g of x? My g of x is the square root of x plus 5. All right, these are not like items, so that's it. That's the final answer. That's the final answer in here. Okay, and what is a minus? Well, minus, we're gonna just using f minus g, using f minus g in here. Look at that. And f is x minus 4. Okay, and minus g is minus this one right here, minus this one. And again, you cannot simplify inside and outside the square root. So this is the final answer. That is the answer. That's it. Okay. And another question here is we want to find a domain for A and B. So how do I find a domain? Well, question here is what's the domain here? Well, since there's no x in the denominator, so I don't have to consider the rule number 1, right? But I do have an x under the square root. So these two domain actually is the same because my radicand is x plus 5. This radicand is also x plus 5 and it's not in the denominator. So my domain for A and B is the same. So I only need to meet the rule number 2. So x plus 5 cannot be negative. That means x plus 5 can be greater than or equal to 0, right? And how do you solve this one? Well, you minus 5 on both sides, minus 5 on both sides. So this cancel out, right? So I have an x will be greater than or equal to negative 5, okay? So how do I write down the negative 5? I just write down negative 5. Greater than will be go to the right-hand side. So using bracket and then go to the right-hand side. That is my domain here. Since I have an equal sign, so I will use a bracket. So this will be negative 5 to infinity. Okay? You always need to write down a smaller number on the left-hand side, large number on the right-hand side, okay? In the interval in here, smaller number, since negative 5 is a smaller number. Infinity, positive infinity is a large number. So you cannot write down the opposite way, it will counter you wrong, okay? So always write down a smaller number on the left, large number on the right, okay? Large number on the right in here. So that is the domain for A and B, okay? Any questions? All right, if not, we're gonna look at the C and D, okay? So what is the C in here? Well, multiply. Okay, so C multiply, I will just using f of x times g of x. Look at that, this is very simple, times g of x in here. So that's, if you don't write anything in here, that means multiply, right? Multiply, if you don't write anything, or you just write down a small dot in here, it's also multiply, right? And that is all multiply in here, okay? So we're gonna just multiply f times g, okay? So f is x minus 4, g is square root of x plus 5, and that's it. You don't have to distribute it in, that's the final answer, okay? If you really want to distribute it in, this will be x times square root of x plus 5 minus 4 times square root of x minus 5 in here. But I will kind of think the homework should be able to accept this answer. You don't have to multiply it in, right? But if you do, that is how you multiply it in, get rid of parentheses, right? So that is this one. And where's the domain for this one right here? Well, the domain for this one, again, I don't have anything under the denominator. So if you want to see the denominator, all my denominator are 1 here, right? You can always think of this, divided by 1. Divided by 1 is equal to itself. So we don't really have to do this one right here. So again, I don't have an x in the denominator, right? So I don't need a rule number 1. I only need to meet a rule number 2 in here. So rule number 2, I have a 2 square root, or these 2 square root are the same, so it will be just 1 square root, right? So x plus 5 cannot be negative, so can be greater than or equal to 0. So this domain and then minus 5 on both sides. So this domain is the same as a and b, and negative 5 greater than or equal to negative 5 using the bracket here going to the right hand side, right? So we have a bracket because we have an equal sign in here. So we're going to have a negative 5 to infinity. So that's the domain for C, okay? And let's see how do we do the D here. D, you have to be careful because D is a division, right? So when we divide something, denominator cannot be 0. So this will be using F divide G in here. Okay, using F divide G. And what's my F? My F here is X minus 4. Okay, and my G here is square root of X plus 5. All right, now I have to be a little bit more careful because I have an x in the denominator. This entire square root is in the denominator, right? So I will have to meet these two conditions. First, the denominator cannot be 0. So when the denominator can be 0, when x plus 5 equal to 0, 0 square root will be 0, right? So this rule number 1, denominator cannot be 0. So this x plus 5 cannot be 0, right? If you solve this one right here, you minus 4 on both sides. So that means x cannot be equal to negative 5. That is rule number 1. Rule number 2, this is also under the square root, which is an even root, okay? And this cannot be negative. So x plus 5 will have to be greater than or equal to 0. And then you minus 5 on both sides, solve this one right here. X will be greater than or equal to negative 5, right? But you have to combine these two rules together. So combine the two rules together in here. That means I cannot include a negative 5 in here. So this must be a circle point going to the right, or using the parenthesis, in here, going to the right hand side. Okay, so what's the interval for this one? So the domain for this one will be negative 5 parenthesis, okay, to infinity. All right, so look at the difference in here. The C, you can have an equal sign because this is not in a denominator, right? For D, you cannot have an equal sign on the negative 5 because this is moved to the denominator. Okay, any questions? This is a very important thing for the domain, right? Because pretty much in this chapter, you're gonna it will ask you to find the domain in here. Okay, so addition, subtraction, which is multiplication, division, is pretty straightforward. But domain, you have to be careful. Domain, you have to meet these two rules. Okay. So for today only, you need to finish 2.1 and 2.2. Okay, we just review this one right here. So you need to finish 2.1, 2.2. You can go ahead and do as much as possible, but this is the minimum. I'm gonna put a due date here. 2.1, 2.2 will be due today. Okay. All right. So that's all I want to talk today. At this point, do you have any questions? The rest of the time will be Q&A. Any questions? All right, so if not, we're gonna stop right here. Okay, we will stop right here. I'll be still online for a while. If you have any question, you can still jump in later on. Okay, so I'm gonna stop recording.